Okay, let me start by congratulate you with the victory of yesterday evening. It was, your football team was amazing, and on behalf of the Netherlands football team fans, we thank you. Okay, now for something different. I'm honored, I'm proud to have the opportunity to exchange our experiences that we have in a interesting project on Internet of Things. And the relation with big data is, I hope to explain that during my talk. I have to warn you, because this is, the project I will discuss is not a research project. It's a project that you can see in what we call in Europe the Valley of Death. So the research has delivered prototypes and how to implement and how to integrate it in farming systems and systems that food companies are working with. It's about integration and implementation. Okay, let's make a start. So what we're talking about is high-tech farming. So it's a lot of information sources on the farm. It's about satellites, it's about sensors, it's about robots, farming systems, farming management systems, external databases, the whole stuff. All the information that is relevant for managing the farming process and for managing the farm. In our perspective, we more and more are, let's say, cautious not to talk only about farming, but also about the food system. So we also involve the supply chain in it. So what we are also covering is tracking and tracing, it's logistics, it's healthy food, it's certification of food. Those kind of issues are included in our thinking on big data and IoT. What I will start is first give you some, let's say, my personal perspective on what's happening in ICT and farming. And in that I will challenge a little bit the concept of big data. Then I will discuss slightly about the European approach on open platforms, and that's an open invitation for cooperation. And then we will go into some details of the projects that we will present and the issues that we run into. I started my career as a researcher in the early 80s. And then the buzzword was decision support system. And the decision support system basically was that you included some data from the farm, from the field, and then an algorithm, and then you delivered some information that could help the farmer to make a decision. So the farmer was involved in filling in the data and interpreting the data and decide to take an action. So basically what you can see is that we are talking about big data, and just for discussion's sake, I think this concept is too vague. Unless you talk about research, that's okay, then we can talk about big data, but when we are entering in the scene of using data for managing processes, for managing farms, for managing crops, animals, etc., it's too fuzzy. So I prefer to use the word completeness of data. Yeah, that's different. And in this is why this let's say exercise on this evolution of the information systems. So in the second phase that I was working in, we got more interest in connecting data with other databases, external databases. And also, and in this, the first, let's say, activities in standardization came up. So we had to implement EDI systems to get data from the bank or from the co-op into the farming system. But the other thing that happened was in those days, we started with process automation. Simple processes, climate control, just sensors, and when a certain threshold was reached, then a decision was made and an action was implemented directly. So that was also coming up in that time. Later on, we got involved in, let's say, internet came available and was easy to use and it was more accepted to use. So then we saw that loads of data could enter the farm, and the decision, the completeness of the information for making a lot of decisions become bigger. And also we saw that the process automation become more advanced, and the basic activity of the farmer in that was to use the correct preset and to respond on warnings from the system. So that brings us to the idea, if we, let's say, if there's no limit on the completeness of the data, you can automate all decisions. So what will be the role of the farmer? Well, the role of the farmer is setting the presets of his farms. And it's about, so the management of the farm is very similar on managing of the, let's say, the simple processes. So this might be the future. I'm not sure about that, but this relates to the completeness of information, and as long as the information is not complete, we always have the farmer to make decisions on this. But you can see already what's going on is that the number of decisions that farmers have to take is decreasing very fast now. Okay, let's make the step to Internet of Things. We did some projects the last couple of years, and where we are now is on using the cloud computing, the clouds. We had a lot of, let's say, startup companies, research projects delivering, I would say, one-dimensional applications of cloud computing. So it's a sensor in the field or on an animal, and then the farmer can see at his smartphone what the data are and make an interpretation, and maybe he makes a decision on that. What we are now talking about is, let's say, the next step, and that's what our project is about. It's combining a lot of data sources and bringing them together in the cloud. And then you have the opportunity to combine a lot of data sources in useful applications with more complete data, so more advanced decisions to make. Okay. The group that we work with is a European group, so we work with colleagues all over Europe. And we found each other because we are working in an open access environment. There was a large-scale initiative by the European Commission to create a public accessible cloud with an infrastructure that it's very easy to use, easy accessible for small and medium enterprises, and so they can do advanced applications with using an infrastructure. For instance, you don't need to make authentication procedures. We have it it's publicly available, you can use it, and it can be used in a lot of applications. So that's the FIWARE program. It's very open. You can use it, and when you have used it, you give your results back to the community, so to say. This was a large-scale program financed by the European Union, and it ended in 2016, and then it was taken over by an ecosystem, I would call it, an ecosystem of companies that are now taking it further and fostering this ecosystem for open access. This FIWARE is a response to, let's say, a European response to Google and Amazon. So we don't want to be dependent on big monopoly companies, but we want to have an environment and an infrastructure that's available for everybody. That's basically what FIWARE is about. So that's where we found each other, and that's where we developed the project, Internet of Food and Farm on. The objective of IOF 2020, as I call it, Internet of Food and Farm, the objective is very simple. It's demonstrating that Internet of Things is meaningful for agri-food, for agriculture and for food. We have to demonstrate it. It should be viable business models for the application itself. So for farming, it should be attractive to use those applications, but also for the providers of technology and the people that are involved in it, in delivering data, but also in let's say, services related to this. So it's about broadband, etc. So it has to be viable business for all stakeholders in the end. That's about the project, and it's working on, let's say, the high TRLs. So the technology that we are using in this project, it's from the shelf. It's already proven and it's there. It's just a matter of combining and integrating it into operational systems of the companies that we work with. So there's this is, let's say, it's a 4-year project, and we have a pretty substantial budget. And it's connecting, let's say, the physical layers with this open architecture environment. And that's what the project is about. We work with use cases, and that's the core of the project. And we have 19 interesting use cases covering all fields in agriculture. So it's arable farming, dairy farming, fruit farming, vegetables, and meat production. And just to give you a glimpse how we developed those use cases, these use cases, by the way, are quite substantial projects in itself. $500,000 on average, €500,000, which is multiplied by thousands, then you have an idea of the budget for each of those use cases. And what we did when we started this project, we invited agri-food companies and farmers and farmers associations to come up with ideas. Who wants to work with IoT? And we got more than 200 interested companies. And then we clustered a little bit, and we selected, of course, and then we came up with 19 groups of agri-food people that are interested in IoT and want to experiment and have some ideas with it. And then we invited the tech companies to provide the technology. So we started really at the user side, and we invited from our fireware community, we invited the technology providers to join us. That's how these use cases are let's say, set up. Yeah, and I just want to give you an impression what we are talking about. If we look at the arable farming, so it's about wheat, it's about potatoes and soy, it's about big machines, about tractors with satellite data, GPS, it's about crop protection, it's about irrigation. And one of the interesting things is this farm-machine integration. What we see is, the interesting part is that we brought together the big machine builders in Europe. And we asked them, are you willing to operate in a way that the tractor of one producer can communicate with the harvester of another? So it's about interoperability. Because nowadays, when you go to John Deere, you have to buy a tractor and then all the machines from the same supplier. And we are not sure what's happening with the data that are collected by those machines, whether they go to, well, we don't know. But this group of machine builders are now, these are the European machine builders, they are working together and making their machines interoperable. So you can buy a tractor from one company, from Arco, and have a harvester from Klaas, no problem. They are communicating with each other, which is, by the way, quite a big success of the project. So that's in arable farming. When we look at dairy farming, it's about giving the cows a collar, so they can, and then we can register where the cow is, of course, which is important when you have cows in the field. You can study how they walk and if there are different patterns. So there are maybe a fox on the territory or something like that. You can see the temperature of the cow, all kinds of data related to the cow. And the three projects, one is on feed management, one is on health management, and one is on herd management. So these three projects are quite similar, and we try to integrate them more and more. The fourth one is an interesting one. It's about milk quality, how to measure milk quality. It's a complex procedure, and usually milk quality is done by making a sample, send it to a lab somewhere in the Netherlands or somewhere in Europe, and then 2 days later you get the protein content, the fat content, and some contamination if there is in the milk. This large project is working on having small units for doing milk diagnostics on the farm. And the IoT component is that we are using IoT technology to calibrate this measuring instrument. So it's, and of course for collecting data. So that's the dairy. In the vegetables, we have an interesting project on city farming, which is farming in multiple layers with artificial light. So we can do it everywhere. And the idea is to have units all over cities and close to customers, and have one central office where you can put the temperature regime or give some more fertilizers, or where you can manage the whole process. That's one. The other one is greenhouse production. So having a lot of sensor in the greenhouse to see how the climate control is, and to see how the crop is growing, and combine those two, of course. And this is also, the IoT part is also that you can have it, the management doesn't need to be in the greenhouse itself. It can be on distance. The added value weeding data is a machine that's looking at what kind of weeds are in the field, and identify the weeds, where it is exactly, and what can be done about it. And the last one, the quality of certification. The quality certification is an interesting one because it's about organic and conventional farming. And there we're using IoT to replace inspections. So nowadays, when you are an organic farmer, the farmer has to keep track of his actions in a logbook. Well, we can replace that by sensors. And also the procedures can be checked by an inspector on distance. Just look at the data in the cloud, instead of visiting farms and checking if the farmer is doing what he has written in his logbook. So this is more efficient certification, is basically the idea behind this use case. In the fruits, we are working with grapes. So it's about the phytosanitary situation in the vineyard, to see if crop protection measure is needed. We have one of the nicest one, the big wine project use case. It's about wine production, so that combines data from the vineyard, data from the processing, data from the cellar where they store the wine, up to the transport and the shelf life in the shop. And the idea is this is about high quality wines to guarantee the customer that all places in this chain are guaranteed and are of high quality, and so the wine has to be absolute top. So that's the idea of this project, to use IoT and collect all the data, and if something goes wrong, you can track down where the problem is originating. The last one is about logistics. In Europe, we have a big company who provides plastic crates for all fresh produce. There are hundreds of millions of those crates. It's pretty standard in Europe. And the company who's providing these crates, they now put a device in it so they can keep track of where the crates are going and where they are. And this gives opportunities not only for traceability, but also if temperature can be measured, humidity. So if a crate of lettuce is not fresh anymore, you can see where it was in the sun and what the problem was. And this logistic part is, well, maybe it's one of the problems that we are facing with, is that if you put a device in a crate, in a box, then you know where the box is. But the box is on a truck. And the truck has a driver. And one of the problems is that if we can trace down the box, we can trace down the behavior of the driver. And that's, in Germany, for instance, it's forbidden. We cannot do that. It's a privacy law that we have to respect. So we have to find a way around this. These are the practical problems that we run into. The last is the Internet of Meat. So we have pig farm management. So that's a lot of details in all kinds of sensors in the pig farm, where we can measure the consumption of feed, the growth rate, etc. And for instance, there's also an acoustic device which detects coughing piglets. If more piglets are starting coughing, then there's something going on and the farmer has to intervene. That's about the pig farms. The poultry, it's on one hand, it's more or less the same as the pig farm. So it's about devices in the flock where we measure the weight of the chicken. We measure how much they eat, how much they drink, the temperature, the humidity, the dust, all kinds of, let's say, climate data are collected. And then they also, I always like this one. When the chicken are ready to go to the slaughterhouse, you have to do catching. You have to catch them. And this catching of the chicken gives a lot of damage. So broken wings, broken legs, and so on. So the chicken catchers, they get a device around their arm. So we can monitor if they are too rude. Yeah? And so there's also collecting data about the catching of the chicken. And then we have sensors in the trucks that bring the chicken to the slaughterhouse. And then the interesting part is that we get feedback from the slaughterhouse. The slaughterhouse say, okay, we have 85% of the chicken was first quality, but we got a lot of damaged chicken. 15% was damaged, so they are downgraded and you get less paid for it. And then you can use all the big data to find out where the problem was. Yeah, so that's an interesting one. You use the feedback of the slaughterhouse. In the last one, the meat transparency and traceability is a project where we are working with standardization organizations. I don't know if you are aware of that, but there are more than 300, then we stopped counting, 300 organizations, worldwide organizations that are working on standards for technical protocols, but also for data definitions and so on. So and with this project, we try to get some insight on who are the relevant parties for the meat sector. So this is to give you an idea of the type of projects we are working on. Like I said, we brought together some people that are interested in applying IoT for farming and for food. To be honest, we were not very strict to find out what they exactly want. We just want good communities. We looked at the combination of organizations in each of the use cases, and we give them trust to work on that. Well, not only trust, we give them some supervision, so to say, and that's in this cycle. The idea is that after 1 year, so it's a 4-year program, but after 1 year, they have to deliver a working prototype. So last February, we had a big meeting in Almeria, where all the use cases presented their working prototype. It's the MVP1. And then we are, from the project level, we have 3, let's say, expertise groups, and we look from 3 angles to each of those working prototypes. We look at the technical part. Is the state-of-the-art technology used? Are they operating with the right standards? That's that kind of stuff. And the second group is looking at the business viability. Is there a value proposition? Do these guys, usually they are technology gigs, do these guys know how to make money out of this? So that's where we look at. And the third one is, we call it ecosystem, but it's basically about how about scalability. So we're doing it in 7 test farms. what kind of farms would be interested, and let those farms, well, let's inform them and let's them demonstrate what we are doing, so they can also give feedback for, let's say, the bigger use. So that's what we do. We look at those and we give each of the use cases from these 3 angles. They get advice, suggestions on how to improve their prototype for the next MVP, because next February they have to be on stage again. So that's how we manage this project. And I think the key issue is that you don't sit and wait for 4 years they come up with an end project, because one of the things that happens when you start a technology project, it will never finish. The technology guys say, oh no, we're not ready yet, we have to include some more fancy ideas. So we really have to push them to deliver. So this is how the project is organized, with the 3, let's say, expertise groups supporting the use cases. So I'm responsible for, let's say, the success of those 19 use cases. They have to be a success. Failure is not an option, the people from the Commission, from the European Commission told me. So, but there's another thing that's going on, and that's, I think, very important also for this audience, is that at the project level, the 3 expertise group are not only looking at the use cases from the perspective of giving suggestions, but they also look for reusable components. What idea, what technology that we have in one use cases can be used in others. Not only in the project, but also for, let's say, people that are working with IoT in Korea, for instance. So, and we're trying to formalize and bring them together in what we call the Iot Catalog. And the Iot Catalog is not only about, let's say, the technology, it's about standards, it's about guidelines, it's about code of conduct, all kinds of things. It's about how to implement a weather station. That's an issue that's popping up in different cases. We have one case who's doing it perfectly, so let's ask them how they do it and give this, let's say, knowledge to the others. That's the idea of this Iot Catalog. And to be clear to you, I'm now, as managing this whole project, I'm very active in looking worldwide for partners, because I want this catalog to be used by many other organizations to enrich it. So you can use what we have and you give back what you have delivered, right? So if you are open for this open access attitude, we can cooperate on this catalog. At the moment, we have agreements on this type of cooperation with Canada, and we are working with Brazil and Australia on it. And well, I would be very pleased if we can do something like that in Korea. This is the consortium as a whole. We are working with a lot of partners. Most of them are in the use cases. Most of them are companies, and they have roots in the agri-food sector. And the interesting part is that in each use case you have, of course, the users. You have the technology providers, which are usually big companies, providing sensors or communication technology. And then we have also SMEs, and the SMEs, they are the integrators. They are combining. These are small-scale, startup-like companies that are doing the integration. And the reason for that is that they have to have the knowledge of the technology, of course, but they also have to know something about poultry or about grape production or about wheat production. So that's why we see a lot of small-scale companies are doing this integration function. And I'm very proud that we also have a Korean partner in this project. It's the Korean Advanced Institute for Technology, which is partner in our project and have a focus on this traceability. So the challenges that we are now working with, so we are one and a half years ahead. We are now studying on the prototypes as they have been delivered. Interoperability and standardization is absolutely a key issue at the technology part. So it's not developing new sensors or something like that. How to come to standards that one the data from one sensor can be combined with the data from another data source. The reusability, it's, when you say it quickly, it's not a complex thing, but how to formalize reusable components, that's one of the struggles we have. So the design of the catalog, we are on our way, but it's, we need to work a little bit more on that. What we see is this new technology brings in new ideas for business models. So we see a lot of decision making, as I called it, is now outsourced to other companies because it's too complex for the farmer, and we are not making decisions about 300 kilos per hectare on fertilizer, 300 or 350. No, it's 311 and 312. That's the type of decisions that we have to make. So it's much more advanced, and sometimes it's better to outsource it because you need a lot of additional expertise, and we see a lot of things going on in that area. So new service providers are popping up in the use cases. Then we have the issue, I call it legal and ethics, but to be honest to you, we try to avoid lawyers in our project. Because the lawyers, they just have their reference is the existing law, which is okay, but it's hampering the innovation. So what we do is we work with codes of conduct. So we asked each use cases, which are, let's say, 5 to 10 companies working together, to make a code of conduct instead of looking at what's the legal situation. And the last point is that we have to cover is security, but that's one that's later on the agenda, but it's certainly a big issue on this. What we are now at the moment, we are also expanding the project because we are working on expanding the ecosystem of our project by an open call. It's actually open right now, and we expect to have 10 to 15 more use cases at the end of this year. And what we are doing in that is we have a focus on covering new countries in Europe. It's European money that we are using. So we are very dominant in the west part of Europe, so our open call is now targeting on getting more partners in the east part of Europe, in the north part. And the other one is that we try to attract more partners in the food industry and the retail. That's one of the challenges that we are facing there. Okay, that's like I said, we are using an open environment, an open attitude. So we are very open for cooperation with any, let's say, substantial project that's trying to do the same experiments. So it's not about research, it's really working with companies and make the IoT work for the benefits of the farming and the benefits of our food. Okay, thank you.